This is a video of another example of a square concentric drop. In class, I did an example that was in our blue book, but I wanted to provide another example so that you'll have a couple of them to look at as a resource. Now you can go ahead and write down these numbers. Feel free to do the problem with me as I'm working through it. Or, if you want to skip to the end and then, I'll post the answers at the end of the video. You can just check your work. Certainly up to you how you want to do this. Okay, so with these concentric drop problems, you're going to be given some information about the overall dimensions. And so at the top, the outside flat to flat will be 10.5. Bottom width will be 7 3/4 inches. The vertical height will be 8 5/8. We're going to be working with 3/8 inch plate, and the joints will be open corner. And I want to apologize up front. I do have a little bit of a cold, and I'll try not to cough too much. But just letting you know. Okay, so what do we need to calculate? Because it's a square concentric drop, all of the sides are going to be the same. And so if you figure out one plate, you've got all the information to make the drop. You're going to be focusing on calculating dimensions for the top width, the bottom width, the length of the plate. You're going to want to figure out the bevel angle, as well as your interior angles at the top and at the bottom. Now, I do recommend that you draw out a plate, and when you're doing your calculations, you can then plug in those answers for those different items onto this plate and kind of keep that separate away from all the math. Because as you saw in class, there's a lot of math that we're going to do, and you don't want to get lost in it. So what I've got here is I drew out a top view of the drop, and I inputted some of the information given. So when I'm talking about the outside flat to flat, that's from this distance to here. Okay, and this is the flat side. Okay, that's what that means. Notice that we've got dashed lines here, and that refers to hidden lines. So when you're looking down into the drop, you're not going to see the outside of that bottom width, but those dashed lines will represent that width. Excuse me, that edge. So the bottom flat to flat is going to be 7 3/4. And then, so what I did is I only drew half of the front view, and that's going to be represented here. Okay. And so this is going to be the center, just as it is up here. And here's our outside. Okay. All right. Now, I also included the height. That piece was given. And then I also had, half. So what I did, because I drew only half, I cut these numbers in half. Okay. And you really want to be careful about writing in the right numbers. As you can see, I made a little error here, and I made the correction, inputted that correct number in, and then we're going to do a lot of math based off of these numbers. So that is really key right here, that attention to detail. Often I'll correct homework and people will get the math right in all the other problems, but they're using the wrong numbers, so everything's wrong. Notice that this triangle here, I've redrawn. It's much bigger because I'm going to be doing some math with this as well, and I want to give myself plenty of space to write down numbers and write down some calculations. Now in this problem, we're going to do trigonometry, we're going to do inverse trig, we're going to do Pythagorean theorem. We're going to round all of our numbers to 3 decimal places, And at the very end, we're going to convert our dimensions, our length dimensions, to the nearest 32nd, and all of our degrees to the nearest tenth. Now the homework assignments will have all that information, but for the purpose of this video, that's how I'm going to be calculating. Okay. Now, again, just to review, we've got several things we want to figure out, and I just want you to be clear that there's no one right way to begin. In the example that I completed in class, we solved for the top and bottom width first. I think in this video I'm going to try to solve for the length first, just to give you that other way of looking at it. Eventually we're going to solve for anything, or for everything, but it really doesn't matter where you begin, and that's what I'm trying to convey. If we look at this piece here, this is the edge of one of the, like the right side, okay? I'll just draw lines here. So if we're looking for the length, that's going to be from this point all the way down here, okay? It's kind of hard to see, but right there. Let's look at this length. It entails two parts. We have this large hypotenuse of this triangle, which represents empty space, by the way. And then we have the short side of this triangle here. Okay? Right, this triangle kind of looks like this one here. And really what's happening is we're rotating it. It's the same triangle, it's just rotated. Okay? So if we add these dimensions, the hypotenuse of this large triangle to the short side of this triangle, we're going to get our length. But now we need to find some numbers, you know. Once we understand what the length is, now we got to figure out the numbers that we're going to use. Okay. Now for this large triangle, you know, we could figure out this hypotenuse through Pythagorean Theorem if we know this side here, which we could easily figure out. Notice that this 5 1/4 represents the whole amount. It's the same from here to here. So if we subtract the 3 7/8, we're going to get the remaining amount, which is right there. So let's go ahead and plug that in. There we go. And I get 1 3/8. Or you could keep it in decimal form, it doesn't matter. I'm just going to write it as 1 3/8 because the space is kind of limited here in my drawing. All right, so we said that we could figure out this hypotenuse through Pythagorean Theorem, and this would be the c side, right? So if we take the square root of a squared plus b squared, that's going to give us this dimension, okay? All right, let's go ahead and plug in those numbers to at least get that part, and then we'll work on figuring out this dimension. So it doesn't matter which one you put in first. I'm going to put in the 1 3/8 plus the 8 5/8. Okay, and I'm going to go ahead and plug that in. Again, I'm rounding to 3 places. Now, if you're building something like this, you might decide to round further out, and that's fine. But for the purpose of the homeworks that I'm going to have you do, and I'm looking for consistency because I have to grade 20 papers, I'm going to have you do it this way. So I'm going to get 8.7339, so 3/4 inches. Okay? So that's going to represent this long piece. And then now we have to figure out this part here so that we can add it to this number, and then we'll have our length. We'll have one answer. Well, let's look at this triangle, and which is right here. Now there is one piece of information that we do have. We have the plate thickness, which is going to be represented right here. Okay, so from here to here, we know is 3/8, so 0.375. All right. Now it doesn't look like we have anything else. So we need to go back here and see if we can come up with maybe an angle or another side. Now it looks like this is going to be the same angle as that. And this is actually the bevel angle, which, you know, we can say this is the bevel. Okay? And the reason I know that is if there's no bevel, that side is gonna be straight up and down. All right? But as I create bevel, the top part of my piece is gonna stick out past that horizontal line. I'm gonna do it again. So 0 bevel, and then as I open it, it sticks out. So this angle is going to be the same as this angle here, right there. Now I know some sides of this large open triangle. I can use an inverse function to figure out that bevel angle. Let's write SOHCAHTOA. So if I reference the sides according to this angle, this is going to be the opposite. This will be my adjacent. I'm going to pick inverse tan to figure out my bevel. So if I go, I'll go down here, inverse tan, opposite, which is 1.375, over adjacent, which is 8.625, and plug that in. And remember, with inverse functions, you want to hit that second button. So second tan 1.375 divided by 8.625, we're going to get 9.0578, so that's going to be 5/8. Make sure I inputted that correctly. Looks like I did. That's going to be in degrees. So my bevel is 9.058 degrees. Okay? Now, one of the things that we wanted to figure out, if I come back here, is the bevel. So off where you have, you know, your side and this, go ahead and write that in. What did we get? 9.058. Okay? So we don't want to forget about that. Okay, let's keep going. Now this is a rounded number, so I'm going to go ahead and draw a line underneath it. Rule of thumb is do not use a rounded number if you can avoid it. However, if you can't, use it. Okay. We have to use that bevel, even though it's rounded, because we need this side. This is our opposite. Our given is an adjacent. Looks like tangent will also work, but not inverse tan. We're just going to do regular old tan. So I'm going to set that up, tan 9.058 equals opposite over 0.375. That's going to be a multiplication problem. We're going to go 0.375 times tan, 9.058. If you're not sure about how I'm figuring this out, how I'm setting it up, I made another video you can review on right triangle trigonometry, and I go over different function setups. So you might want to review that if you're still not sure. Now I got 0.0597, so it's actually going to become 0.060. And that's going to be over here. Now, let's go back. The length is from this point all the way down here. We figured out the hypotenuse of this large triangle. We just figured out the short side of that little triangle. We're going to add this number to this number. So I'm going to rewrite that. So length is going to be 8.734 plus 0.060. And I'm going to get 8.794 inches. I'm going to write that down right here on my picture. 8.794. Okay, we're making progress. All right, now I'm going to go ahead and solve for the top and the bottom width. Those are pretty similar. Once you do one, you kind of get the idea of the other one. And if you look at this top view here, what we want to do is find the dimension from on the inside. What we're given is outside to outside. And because there's a bevel, we can't just take 3/8 from both sides. We have to account for this hypotenuse here, okay? So if we look at this drawing, here's my center, here's my outside. I actually want to get to this point. Now I know from center to here is 5 1/4. If I figure out the hypotenuse of this small triangle, subtract that from 5 1/4, then I have half of my top width. Once I have half, then I can just double it, and then I've got my top width of my plate. So let's go ahead and figure out this number. Let's go back to our triangle. This was rounded. This also was rounded. In fact, it's a double rounded number because I had to use a rounded number. So let's not use the opposite side to calculate the hypotenuse. Don't use Pythagorean. Let's use cosine. Okay, we're going to use adjacent and hypotenuse. That's going to be cosine. So here we have, and let me do the math over here. Cosine 9.058 equals adjacent, which is 0.375 over hypotenuse. That's going to be a division problem. Excuse me. Let's plug that in. It's a little bigger than the thickness, 0.3797. So I'm going to make that 0.380. Okay, let's go back, review what we did. We wanted to figure out that number so we can take it away from 5 1/4. I'll do that over here. get 4.87. That is going to represent half of my top width. I'm going to multiply this number by 2. I get 9.74. So top width is going to be 9.74 inches. Okay, I'm going to transfer that information over here. Okay, we're making progress. Now the nice thing about the bottom width is that we're kind of doing the same thing. We're just using a different overall width. Instead of subtracting the hypotenuse from 5 1/4, we're going to subtract the hypotenuse from 3 7/8. Then that would represent half of the bottom width. And then once we double it, we've got the full bottom width. So I'm going to do another math problem here. And we're going to subtract this amount again. I get 3.495. Okay, I want to double that. I get 6.99. This represents the bottom width. And I'm going to go ahead and put that right here. Okay. Looks like the only thing we have left are the interior angles at top and bottom. So I feel really good about seeing the light at the end of the tunnel. It's nearer. Now, I think what I'm going to do, I'm going to redraw this because we're going to use some of the information, but it's a little crowded here. So let me just quickly redraw that. And I'm not going to fill it up with a bunch of stuff. Let's see, 1, 2, 3. I'll do that. All right, so we have our, I'll go ahead and plug in the top and the bottom, 9.74, and then we had 6.99. Now, our goal is to create some right triangles so that we can do some more math. And what we're looking for here is this top angle and this bottom angle, and it doesn't matter, you can do it on that side. Now, if we subtract the bottom from the top, what we can do is basically pull this out, and then you're left with two skinny right triangles on the ends. Okay? You can just imagine that gets taken out. Or if you want, you can squish them together once once you do that math. I'll go ahead and draw a representation of that. Okay, So basically what I'm saying is if you subtract 6.99 from 9.74, you're basically pulling this out, and then you could squish the ends together. And if you bisect or cut this in half, then we basically have, you know, if you look at just 1/2, you know, I can color in 1/2, that's what this is here. And so essentially we're getting this dimension here. So if you subtract and then divide by 2, that's going to give you this dimension. Okay? And so, you know, I'll go ahead and redraw it here just for the purpose of a visual aid. We're just going to work with the one triangle, not with both of them stuck together. Okay, so here, colored in. All right, now we know the length. We've already figured that out, and that was going to be 8.794, and that's up here. Now, if you do this calculation, let me find my calculator. You're going to get make sure you divide by 2. You're going to get 1 3/8, or 1.375. I'll just leave it in decimal form. Excuse me. Okay, let me move this. Now what we want to try to figure out again is this angle and this full angle. Now notice this green triangle, you'd only get this little part. If you figure out this and subtract from 90, you would only get this little sliver here. But we want to make sure the 90 is included. So I like to solve the top first, and I have a little trick to figure out that bottom with the calculator. So I'll go ahead and show that to you, and I promise we'll be done soon. Alright, so I'm going to figure out the top, and I'm going to use, well, first let me label my sides. This is adjacent, this is opposite. I want to figure out this angle. I'm going to hit tan, inverse tan, opposite over adjacent. All right. Second tan, 8.794 divided by 1.375. And we're going to get 81.113 degrees. That's the top angle, top interior angle. Now the trick is, don't erase this number in your calculator. Now if we subtracted this from 90, we would just get this little sliver, but then we would have to add 90. And you can certainly do it that way. But a shortcut is to just punch in 180 minus, and then hit second answer, and that brings up that number. Okay, enter. And so that's going to give you this full bottom interior angle, and that's going to be 98.8866087, so 0.887. Now, if we were to add these two numbers together, we should get 180. So let's go ahead and do that just to double check. Sure enough, we get 180. If these are, if you don't get 180, then you want to go back and review your math. You might have punched in something incorrectly. Sometimes that happens. All right, we are almost done. For the purpose of the homework, like I said, you're going to write out your answers in a certain way. So first, before I do that, let me just plug in this information. My top was 81.113 degrees. The bottom was 98.887 degrees. So for the homework, you're going to convert your length distances, or your length dimensions, to the nearest 32nd. So let's go ahead and do that, and I'll just write them in parentheses here. But this is how you would write it out for your typed out answer sheet. So we're going to go 0.74 times 32. 23.6, that's 24 32nds. That's going to reduce to 3/4. So 9 3/4 for the top. 0.99 times 32, that's 31.6, so that's going to round to 32, which is going to bump that to 7 inches. 0.794 times 32, it's 25.4, so that's going to be 8 and 25 32nds. Now for our angles, we're going to round to the nearest 10th degree. So the bevel is going to be 9.1 degree. The top interior angle will be 81.1 degree. And the bottom bevel will be 98.9 degrees. And that will be all. Now, one last thing. Your answer sheet, you're going to type up your work, and let's just make believe this is the typed up work, and this is all your work. Let me zoom out so you can see it. So this is all the work that you did. You're going to fold it in half, and then on this left-hand side, you're going to open it and kind of make like a dog ear and press. And then you're going to take your typed out sheet and then staple it in this corner. So let me find my stapler, and I'll show you why I like this. Okay, so I'm going to correct your work like this, and then I'm going to open it up, and then I'm able to open and see all of your magnificent calculations. And then if there's a problem with any of your answers, I can see what's going on. Okay? Try to be neat and organized. I know this is tough. There's a lot going on here. But like I said, you know, this is important. You're going to be building things like this out in the shop. And this is kind of a precursor activity to the garbage can, which I'll do a video on that as well. So anyway, I'm going to post the answers. So in case you skipped all of the other stuff. Oops, get this up here. Sorry about that. There we go. Here are the answers. Let's see. So we've got 9 3/4 for the top, 7 inches for the bottom, 8 and 25 32nds for the length. The bevel is 9.1 degrees, and the angles are 81.1 and 98.9. If you have questions, come to class with them, and I'll do my best to answer them.